Okay, yo, what's going on, guys? We are live, back in the building. Jordan, oh, hey, who's usually that comes number one? I think Lowry usually is like, yo, hi, what's up, number one, first commenter. But first we got Jordan today. What's up, Jordan, buddy? 13BTX, what's up, my man? I don't know how to say your name, number three. I'm just going to call you Ian. Ian P, what's going on, bro? Oh, fuck. They're getting more extreme as it goes along. Number four, I'm going to call you Johnny. How's it going, buddy? Phoenix, Ryan, what's up, what's up, what's up? Tonight's going to be pretty interesting, I think. Tonight we're in for an interesting one. I don't have basically, I have no idea whether this is even possible. So I'm going to kind of experiment with you guys. And maybe we can make something work together. It's the eclipse in the USA today. Yes, I saw some pictures. It looks absolutely insane. Can you shout out my daughter? Steve, can you just do a phonetic spelling on how to say that out loud? Because I don't want to say it and pronounce it incorrectly. So yes, this evening's stream hopefully should be an interesting one. We're doing something that I've never tried before. It passed right through my town, man. That is sick. Lucky you. Hopefully you got some good pictures. Good afternoon, Leroy. Tron, what's going on, buddy? I just now put together that kicker ZX 1500 yesterday. Nice. I can't remember what one that was, but Neve. Is that right? Wait. Hang on. That doesn't look like it's. Steve says phonetic spell K-N-E-E-V. To me, that sounds that would spell Neve. And is that spell N-I-A-M-H, Neve? Wow, that's crazy. I would never have thought to pronounce it like that. It's Irish. Got you. What's up, Neve? Good evening. I hope you're having a great time. And I hope that, well, yeah, just hope you're having a great time. Hope you're having a great, what day is it even? Monday? Hope you're having a great Monday evening, Neve. This is a mess. What's up from Kenya? Greetings from Ireland. I'm going to call you Andy. Found your channel this morning. Great stuff. Keep on rocking. Man, appreciate you. Thank you very much. What video did you find my channel from? Was it the, probably the Zapco, maybe, video? So, yes, just while the stream gets kicked off, I'm just replacing a drive IC for this Band Viking 15K. It looks a little blurry, actually. I'm not sure why that is. Let me zoom out a bit. I was zooming in too much. And as you can see, the board is in a pretty bad shape. I'm actually just going to go and message the guy who this belongs to, because he might be kind of interested to see this stream. Gatis. Hey, buddy, comma, just live on YouTube now with your Viking amp, comma, gonna try and retrofit the TL494, I've turned into a right boomer using voice to text, but it works so fast on this new phone, it's just literally quicker than typing. And see how it goes, lol. Just in case you wanted to jump on and see what happens, haha. It's weird, semi-dark here. Oh, fair play. I'm in Jamaica. What's up, Leroy? Hope it's cool in Jamaica right now. She's blushing, thanks. Oh, adorable, that's cool. No worries. Right, let's fit this drive IC, and then we can get started with the main event. Now, this might take a little longer than I planned, because as you can see, the board is in an absolutely horrendous shape. We basically the drive ICs on these amps, they absolutely get cooked when the power supply FETs burn. And the drive ICs burn as well, and they burn the PCB. So all the traces are all over the bloody place, and it is a total mess. So what we're doing first is just going to clean up this area a little bit. The traces are all damaged, so we're literally just having to kind of glue the drive IC in place and then just solder each of the whatever remains of the traces to the IC, and yeah, just literally put it back together like that. But once we've done this, we'll be able to start work on retrofitting a TL494 in place of the MCU, which is something I haven't done before, and I think you guys might find kind of interesting. So I just want to confirm where this trace is supposed to go. So this trace links to, does this link to a gate, or does this link to, yeah, probably side B? Yeah, okay, this is side B gate. Alright, so side B gate, you want to link to pin number, second down from the top. Okay, so that's like literally right there. And then this one right here, where does that link to? Ground, 12 volts maybe? 12 volts in, okay. So we got 12 volts in there. Now where did that trace can't go? Oh, that's this one maybe? Nope. What was that for then? Ground? So there's a trace that's just kind of floating here. And it should, here we go. That trace goes to input there. That's one of the pulses coming from the MCU originally, and that's another one of the pulses coming from the MCU originally. So I'm a bit confused where this trace went. Here it is. I see it now. It's literally just hiding under there. Good job we spotted that. That's the trace. There we go. Yeah, that's the trace that was originally supposed to be connecting to pad 2. Okay, yeah, this is a freaking mess and a half. Ground is this one over here, which is correct. And VCC is the third pin down. So is that even going to reach? It's not, is it? Alright, let's just lift that up out of the way. And I'm going to solder the chip down to what traces are left on the main board here. Actually, you know what, that's just even fallen off, so that's fine. So we're just going to solder it to ground, and then this, which is the A side drive. And then we'll just have to tack in all the others. What a mess. This is probably the worst one. I'll show you all the others I've done so far. Oi oi, Kush from, how's it going, buddy? Oh yes, the Zapco video shocking how their amps leave the factory. Indeed, buddy, indeed. I was very disappointed. I don't care, like, you know, that amplifier, aside from the turn on pop issue, most people that aren't super critical into SQ probably aren't going to notice that. And if that amplifier was reasonably priced, if that was like a bargain price, I wouldn't be too mad at all. I'd be like, yeah, it's got a bit of a turn on pop, this needs correcting, but at the end of the day, this is going to make decent power for the money, and the build quality isn't terrible. I've seen far worse. Yes, it's pretty bad, but it's not the worst on the market right now. But the amount of money that they are asking for that absolute pile of garbage, that's what makes me cross. So yes, it is sad. Phoenix Gold went the same way as well. I don't know if they've redeemed themselves at all. I know that there was talk that they were starting to sort out their quality a bit. But yeah, Phoenix Gold went that way as well. Obviously, Hyphonics went that way. Obviously, PPI went that way. Lots of brands have gone that way, sadly. Okay, this is the big chunky ground trace. Come on, get you connected. My man, 13 BTR with a 20. Jeez, my dude. You don't need to do that to ask a question, buddy. I appreciate that so much. Holy crap, that is a lot of money, dude. Coming in hot. Hang on, let me just read that in a second. I want to give that my full attention. Just going to finish soldering this in. You know what? I think I'm going to need the iron because that ground trace has a lot of thermal mass on it. Put a bit more flux on there. I don't think the little hot air gun is going to do that one justice just now. So let's just get that on there, and then we'll have to, yeah, fuck, there's like 1, 2, 3, 3 hanging traces, and then a couple more that we need to rebuild on this one. And the main topic for this stream, we will start as soon as, pretty much as soon as I've soldered this bad boy in. So I'm doing this left-handed. I rarely ever use my soldering iron with the left hand. So let's see how this goes. Okay, there we go. Oh, that's not too bad. Oy. I think, you know what, I think that it's welded the original leg, because that trace there is like hanging in the air. Yeah, it is. Bloody hell. Right, now let's tack it in on the other side as well, on this trace, which remains the only trace that remains on this side. Oh, bloody hell, this is the worst. This is one of the worst ones I've seen. Right. Oh, Jesus! How many attempts are we going to get at this? Come on. Right, you go on there. Right, that's a bit better. Right, there we go. So 13 BTRX. Had a quick question. Does only running one RCA to a monoblock amp have any downside? Trying to conserve channels on my DSP. Wow, that's a nice easy question for 20 bucks, buddy. Thank you very much again for the donation. That's crazy. That's a decent review. But in answer to your question, there are on paper downsides. The only downsides to running one RCA is that you get a little bit more, a little bit less signal to noise ratio. So obviously the less that you need to increase the gain on an amplifier, the less background noise you're also going to be amplifying. So the stronger your signal reference to the noise is, then the less noise you're going to have through your system, less floor noise. But if it's for a subwoofer amplifier, that doesn't really matter, because your subwoofer is not going to amplify or not really going to reproduce sort of background hiss and noise like that, so it doesn't really matter. So the only thing that running one RCA will do is just mean that you need to turn your gain up a little bit higher than you would otherwise need it for 2 RCAs. It makes no difference. There can be some arguments said for, well, if you only run one RCA from, like, say, the left hand channel, for example, then you're missing out on any bass that would be on the right hand channel only. But like in almost every single song in the world, frequencies under like 100 hertz are going to be mono anyway, or centered anyway, unless you're listening to some movie with Atmos and it's got like an explosion on one side or whatever, and they're making that be a thing. But then the bass would also be monoed for sub LFE anyway. So yeah, honestly, not a problem at all. You can just run one RCA, increase the gain a little bit to compensate for just there being one RCA, but again, yeah, it doesn't matter at all. But yeah, thanks again for the 20, man. I really appreciate that. You're always dropping bucks on my stream. I really appreciate this. My friend has a Stetson 8K and it would stop playing sometimes. The fix was a well-aimed punch. Bit of vibration damage. Stetsons are not built very well, especially with the inductors and transformers, but also, to be honest, the legs of the MOSFETs. The boards have a bit of flex to them and they snap parts. So if the amplifier still currently works and you sometimes have to whack it, then stop using it immediately, because whatever part is broken can result in a complete total meltdown of the amplifier. At the moment you've got lucky in that whatever part is snapped is not causing a critical meltdown. Like if one of the gate legs was snapped, then that MOSFET will just phantomly turn on and explode and then kill the drive circuit and everything else along with it. So dismantle it now while it still works, but with a snapped something, and find out what the snapped something is or the rubbed something is and fix that while it still works, because that's an easy fix. Whereas if it melts down, that's not an easy fix. My Fluke 179 multimeter screen goes blank. Dude, to do amplifier repair, you don't need a fancy multimeter. Just any cheap multimeter with a continuity beep and you know, ohm setting is all you need really. You're going to be using your scope for voltage measurements and pretty much anything else. Your multimeter for amplifier repair is literally just there to go beep when there's continuity and to measure roughly the right resistance. Don't need anything expensive or fancy. Oh, you can combine left and right in the DSP. Well, there you go then. Awesome, sorted. Oh, dude, David, how's it going, buddy? Is there a way to tell which DD red lines 8s I have? They don't have a sticker to say what ohms they are. Oh, man, grab your multimeter out the drawer and just test it, bro. Oh, they're the ones you sold my mate years ago, if you remember. Nah, I don't remember at all, bro. This is a long time ago now. Yeah, get the old multimeter out. Get the old multimeter out and have a bitches. See what ohm it is. Anyway. What we need to do now is we've got this drive IC soldered in, but pretty much all of the traces are hanging here where they have been burned to pieces. So this trace here, if I remember rightly, well it was, was the one that came from, I've just pulled it off, but that's fine. It's the one that came from this 4R7. Now this 4R7 resistor here, well, my camera's very blurry this evening, I'm not sure why, but this is a 4R7 and this runs in line with the VCC supply to this chip, which is going to be down on pin 7. No, sorry, pin 6, pin 6, pin 6. So pin 6 here. So we need to just run a jumper from here to pin 6. No worries. Let's do that now while we can, while we're here. Let's get a little bit of wire here. Please read this as it might help people with their Pioneer head units. White death screen head units, as I said before. NAND flash memory chip is what makes the problem for me. Just resolder the chip and fixed. Yes, cool, good tip, buddy. So yeah, if anyone's experiencing problems with their Pioneer head unit with the white screen, give that chip a reflow, NAND flash chip a reflow, and it should be good to go. Depends why it needs a reflow though. If it needs a reflow, excuse me, due to like the solder balls cracking or becoming, you know, cold solder joints, then that's fine. Reflowing will fix it, you know, indefinitely until it happens again. But if the NAND flash chip is actually going bad, then heating it to the point where the solder melts, that can sort of bring the chip back to life temporarily, but it's never usually a reliable fix going forward. So it depends why. It depends why the NAND flash chip needs heating. If it needs heating to reflow the balls, you're fine. But if it's like failing silicon, then heating it can bring some life back into it, but it might only be temporary. Same goes for graphics cards and all sorts. So I'm just putting a little bit of fresh solder on that 4R7, and then also dropping a little bit of solder onto pin 6 there. That's a bit much actually. That's a bit much. I have to get some of that off there. Let's get the main iron here and just get some of that off. And then what we want to do is take our little strand of wire, which seems to have now disappeared. I'll grab a new one. And we want to solder that to the 4R7 VCC. There we go. And then we just want to curve that round into pin 6. So it's going to be just there. So for any of you that have just joined, this is a Band of Viking 15K with a completely toasted power supply section. And just before we get into the main event of this video, which is going to be seeing whether we can retrofit a TL494 oscillator instead of using the MCU for oscillation of the power supply section, we need to make some repairs to this drive circuit. So we're just doing that first. get that all up and running, and then once the drive circuit is repaired, then we can turn our attention to the main event of this live stream, which is hopefully the MCU retrofit. That looks good. Alright. So that's our VCC supply sorted. Now, what do the other pins do? Well, this bottom pin here is side B, gate output, I think. Side A output is there. That's VCC supply. Ground is on pin 3. Pin 2 is coming, I think, from... Yeah, pin 2 is going to be coming from this top resistor up here, which is PWM input. So this little trace here that's hanging over the top of the board, that needs to be on pin 2, and that's actually very close. You know what, I think we can literally just solder that trace directly to the top of the chip there. And then this trace up here is PWM for the other side, and that one needs to go into pin 4. Pin 2 and 4. Okay. Is there enough length on that trace actually to make it down there? I think there actually even might be. Yeah, I think there actually might be. Bend that leg up a little bit. I think that might be okay. So I'm just going to drop some flux onto pin 2. And also pin 4 there. GMR Works! Yo, what's going on, buddy? So basically, guys, in the live chat, GMR Works is the owner of this Banda Viking, the unfortunate owner of this Banda Viking 15K, which has given him nothing but trouble for... I don't know, best part of 6 months now, maybe. And it all started with, I think, a blown power supply. Was it? I can't remember, Gattis. Was it a blown power supply by itself, or was it a blown output section that killed the power supply, which then led to this nonsense with the getting a replacement MCU sent over? But either way, this has been a massive headache due to a dead MCU, which is the microcontroller that controls PWM for the power supply side of this amplifier. And Banda, unlike Taramps, Banda are not willing to supply replacement MCUs to third-party repair centers. So as a result of that, there's a lovely gent in America who has written his own sort of firmware to mimic the firmware in the Banda MCU, and he's done a great job of it. But the problem is that every single time every single one of those chips that we fitted from my good friend in America to this amplifier, the power supply has spontaneously self-destructed while not under heavy load, just running low volumes or whatever. The power supply has just all FETs dead. With no output section damage. Now, power supply sections don't kill themselves out of nowhere. A power supply section in an amplifier will only fail if there is some glitch or problem with the drive going to the FETs for the power supply, or something shorts either a transformer or something on the rails, which will be like an output section fault. None of which we have here. All of these transformers are perfectly fine. We have no issues with any of the transformers rubbing or shorting. They're seated down really well. There's no risk of vibration damage in Gattis's build either. It's absolutely solid and beautiful. So the only thing that we can then pin the blame on is a drive glitch, something that is screwing up the drive to probably all banks by the looks of it of FETs here. And the only thing that we can really put the blame to is the MCU that provides the pulses. And given that it's not a factory MCU, it is one that's been programmed by someone that's reverse engineered it. Now, he's done this for other people, and apparently their amps are fine, so I don't really know what's going on with this one, but as far as I can tell, like everything points to the MCU being the reason that this keeps failing. So what we're going to do in the stream today is we're going to try and retrofit a old fashioned style oscillator to this amplifier by using a TL494 in conjunction with the original MCU. So I still have the original MCU for this amplifier, and the original MCU still functions, but the oscillator part of the MCU is damaged, so it doesn't actually output pulses to the power supply section anymore because it was damaged from backfeed from the drivers when they blew. But the rest of the MCU still works fine, so all the original code still works fine in there. It's just not outputting any pulses, or it might be outputting pulses just on one bank on one side, which is obviously not ideal, but we can potentially use that to control the TL494 with our own circuitry. So let me just go through this one last time and just make sure that all the pins are connected where they should be on this. I think one pin actually is not connected where it should be on this driver. We should have, I think it's bank, where does that go to? Bank, pin number 7. Pin number 7 goes to second bank over here, so that is this trace right here. So yeah, we do still need to do one little cheeky trace repair, and we're actually going to have to jump over that that wire that we soldered there. So that's going to look fun. It's going to look like a schematic. So basically we've got a wire bridge there for the VCC supply, but we also need to make a connection to this trace here, which leads over to the B side of power supply FETs. But obviously we need to jump over this that we've just made. So this is going to look fun because it's going to look like a schematic. So let me scratch off here so we can solder to that trace. Okay, and then we just need a little component leg. Bonbon says, would you know how to fix a guitar amp with the built-in tuner and FX don't work no more, just the amp still works? I don't work on guitar amps, but you know, amplifiers are amplifiers, but I'm not familiar with that circuit or that brand or anything like that, so I probably wouldn't be able to offer any meaningful advice, I'm afraid, buddy, sorry. So let's tin this trace that we've just scratched away at, and then just going to solder our lead. Okay, so that's our wire connected to the trace. And now what we need to do is we need to make a little bridge over troubled water. No, over the other trace, that the other hatch lead that we've made there. So let's pin that down there. Jump that over there. And spin it round, and cut it a little bit because it's a bit too long at the moment. And there we go, that is ready to solder. And yes, unfortunately, because of how these fail, this looks like an absolute mess, doesn't it? But it's the only way that we're going to get this amplifier back up and running again, unfortunately. And there we go. Excellent, nice and strong. So let's take some isopropyl alcohol and clean that off. What a bloody mess. But everything is connected where it should be. So bank B over here, yep. VCC, bank A over here, yep. Input B, ground, input A, yep, and then the other two pins are floating because they're not used in this circuit. So we have a connection on all the drivers. So you see obviously the state of this one. Let's have a look at the state of some of the other ones. So that one's like that. This one looks like that. They're all like this, unfortunately, due to how badly they burn the PCB and traces when they fail. That one is a bit better. And then go over the other side. That one's like that. That one's like that. And that one's kind of okay. The reason they're not using insulated wire, so because the runs are so short for these little patch leads, I pretty much have to scratch away almost all the insulation anyway, and to be honest, it just takes more time. Like, there's no risk here of any of these shorting to anything else due to being exposed wire. So yeah, using insulated wire here isn't going to really add any benefit or anything. It's just going to take more time to do. If you're running wires over a very complex board that had loads of different traces and all sorts of like exposed traces or exposed components that you're having to run around and stuff, then yeah, absolutely use an amplifier. But in this case, it's just like a really short little jumper from one trace over to the pin of the IC, so it's just quicker to use a bit of component leg. Do they provide most marshmallows with those amps? Yeah, they're funny. These amps aren't the worst, to be honest. The design is okay. They are burp amps. They're not really designed for like long-term music playing. They're very rough and ready. They're very basic amplifiers. But they are pretty beefy, to be fair. It's just a shame when they fail and they take out the MCU that we're left with all this mess. Anyway, now we have got all of these drive ICs connected correctly, regardless of what a mess it is. We now can grab the main board. This is where it gets fun. And we can try and retrofit a TL494. And this is what I intended the stream to be. So let's grab the main board. Just here. Okie dokie. So, let's get cracking with this. Now, the MCU that creates and sends those pulses to the power supply section, which is what we're suspicious of, is right here. Now this is one of the MCUs which, as I mentioned earlier, my good friend in America has reverse engineered the program for and has written his own program to. Look how nicely that's soldered, you never know. So because I'm suspicious, like everything points to this being why the power supply section keeps failing by itself. So I'm going to actually remove this. I don't actually even know if it's in healthy working condition or not after that failure, but it doesn't really matter because we're not going to be using it anyway. What I'm actually going to be doing is refitting the original MCU that was in this amplifier from factory, and that one is damaged. The oscillator inside the original MCU is damaged, but we're not going to be using the original oscillator, so that's okay. What I want to make sure is that there is an original MCU with the original code that comes from Banda. That's what I want. So we're going to be removing this one and refitting the original MCU, and then trying to retrofit ourselves a TL494. There we go. Okay, so let's put this to one side. Now if I find all of my MCUs, see, look, these are all the MCUs that I've currently got in this little box here. I've got a pick for a HD 15K. I need that because I'm going to be rebuilding a donor 15K soon. I'm not sure what these ones are. Can't remember. That is something for driving power supply effects, I think. That is something again for driving outputs. That is level shifters. Something. This is a MCU for HD 5000, 6500, 8000 and 4000. That's another Teraamps one. See, Teraamps are great. They send you all their bloody MCUs. It's fantastic. Okay, now, aha, here we go. So here is one of the little containers that came from my good friend in the States, who made me some MCUs. So let's just drop that back in there. So we know that's Span Viking 15K, no idea the condition. But this one right here, this one in the white paper, this is the original one. So this is the original one from the Viking 15K that my good friend used to take reference from to reverse engineer the code. So we're going to fit that one back in place because we know that's got original code on it. Even though its oscillator is damaged, that's fine. That's not the problem because we're going to use something else. So let's pop that there for a sec. Yo, is Boomer Bus returning? I want it to return. I do want it to return. Actually, on that note, I just wanted to talk about Boomer Bus a little bit. How many viewers have we got currently? Obviously, who's watching my live stream at the moment isn't the entirety of the Boomer Bust audience, but so if I'm going to make Boomer Bust Season 2, it's going to have to perform better somehow. It's going to have to either break even money-wise for me, or it's going to have to ideally make some money for me. So, in addition to it being really, really entertaining, of course. So, I've got a couple of options for Boomer Bust Season 2. Basically, Boomer Bust Season 2, I can either make the videos be somewhat, what's the word? Not uncommon. Basically, I can either do Boomer Bust Season 2 where the videos release whenever I feel like they're ready, or whenever I feel like I have free time to do a Boomer Bust video, knowing that it might actually net me a loss. So the videos might be once every 2 weeks, once every 4 weeks, once every month and a half or something like that. There might even be a 2-month gap in between episodes. I don't know, because it depends on how busy I am and whether I've got time to give to making a Boom or Bust episode if I do a Season 2. So that's one option, is that the uploads will just be sporadic whenever I have time to do one. Alternatively, I can make Boom or Bust potentially be make it be a YouTube membership only series, which would suck obviously, because then not everyone would get to watch it if they don't want to join the YouTube membership. But by doing it as a YouTube membership series, I would then probably be able to make them weekly or bi-weekly, probably bi-weekly, as in like once every 2 weeks, just to make sure the quality is still good rather than trying to rush them and get one out a week. So the question then to you guys would be, would you rather they just be sporadic but free, or would you be willing to join a YouTube membership for, or like a Patreon or something like that for Boom or Bust? But I'd probably do it as a YouTube membership because I feel like that's more accessible. I've got no sponsors for it. I probably could get a couple of sponsors for it, but the sponsors, like, because it's a pretty small series, doesn't get that many views, I can't charge a lot of money for the sponsored stickers and stuff like that. I don't have like a video sponsor. You know how YouTubers get sponsored and they have like a segment of the video and they say, this video is sponsored by shit VPN, whatever. Yeah, obviously I don't have any sponsors like that because they pay big money. So have you still got the Proton and still basing? Yep, still got the Proton, still got the van, just waiting for the summer. Where did you get that vent nozzle? The nozzle's from eBay, I think. Quad Feed, how's it going, buddy? Do it behind Patreon. Patreon's a little bit inaccessible to everyone, though. Conservator with the €6. Thank you very much, my man. To the Bear Vids Fund. Free vids, please. I appreciate you. Thank you very much for that, dude. That's really, really kind of you. Yeah, I would love to keep it free, obviously. Sporadic would be good, says Kush From. So, but yeah, thanks very much for the €6, man. That's really kind. So yeah, obviously I'd love to be able to keep it free, and I guess we could see how it goes. But if the videos really don't do that well, then I might have to consider doing it. Dude, I'm before the van. We stopped talking before you had that, I'm sure. I'm before the van. Yeah, I know, but I don't know. I thought maybe you had seen the van in recent times. I don't know. Let's get this MCU soldered back in then, shall we, gents? I'm gonna switch the tweezers I'm using because these ones actually aren't that great. Oh, the hat cam is not working. Okay, yes, I haven't actually activated it yet so far on this stream, so let's get that activated. Now, where's some other tweezers? Here we go, these ones will do. Okay, so pin 1 is the other way. Thanks very much, love your content. Thank you very much, Conservator. Appreciate you, buddy. Get those legs cooked up. I'm going to try and avoid heating the actual MCU itself because they're probably a little bit delicate. Whoa, dude, Jan Eric, thank you so much for the 100 NOK. I've no idea what that converts to UK, but it's a yellow one, so I think that's probably like a decent amount. Thank you very much, my dude. Appreciate that. Holy crap, you guys this evening. I'll nuts get some filament to do more Boom or Bust. Thank you very much, buddy. I really appreciate that. That's really kind of you. Yeah, little things like this really motivate me to get cracking with the season 2 and just make it be a free series. So that's awesome. Thank you so much, buddy. And that's your first super on a live stream by the looks of it. Thank you so much, buddy. I really appreciate you, man. Yeah, alright, well, let's do a season 2 then. Fuck it. I have to make some plans, work out whether we're going to do... What should we do then? What should we do, guys? Should we do... So I use the same driver that we used for season 1. I was actually thinking of having a few different drivers, a few options. So for season 2, this is what my thoughts were. Season 2 Boom or Bust, this was what my thoughts were. Instead of fixing the driver that everyone has to use, okay, having 3 driver options, which would simulate a single 15-inch, a 12 or 2 12s. You could choose to do 1 12 or 2 12s, or maybe like 1, 2 or 3 10s. So I'd have enough drivers for you to be able to select like 1 15, 1 or 2 12s, or 1 to 3 10s. But the thing that would be fixed would be basically the box size. Now I know that we did technically fix the box size in season 1, but that was massive. I gave a very, very large build area to people, and unfortunately that got taken advantage of, and in a way that didn't really show what was the best performing box for a given space, because the best performing boxes were just the ones that were freaking massive, took up the whole cabin, therefore creating more pressure in what little cabin was left. And in that same space that box filled for a single 12, you could fit a box with 4 12s and be louder. So I think for season 2, what it's going to be is, it's going to be how loud can your box get for a given size. And that will hopefully make the competition be getting the loudest from a given size rather than getting the loudest from a single 12, because obviously to get the loudest from a single 12, then you can just make a massive box, great big quarter wave horn or something like that, and obviously it's going to be loud. But I think getting loud from a given space is what people care about more. People have a given amount of space in their vehicle, they have a given trunk space, they have a given amount of area that they can use for an audio subwoofer build. And they don't care whether they use 310s or 212s or 115 in that space. They just want the most bass they can get from that space that they've got available. So I'm thinking that would be a good route to go down for season 2. You should learn to read out the firmware and reprogram your one. Yeah, I'd love to do that. It's a bit of a learning curve, I think, and I haven't had the time to dive into that, but definitely I would love to learn that for sure. But I think the issue is with a lot of these MCUs, the firmware is kind of encrypted or locked or whatever. You can't kind of read it off it, so you have to like reverse engineer it. Did you buy the Sony phone, Anders? Yes, boy, I did. Oh yes, look at that gorgeous Xperia 5 Mark V. I'm in love with it. The cameras are next level. Like, they're not a point and shoot thing like a Pixel or an iPhone. You still get great pictures with it in point and shoot, but the manual mode, oh, the pictures you can get with it in manual mode is sick. Do a different cabin, make it a saloon, and the box has to fit inside the boot. That's the kind of thing that I'm thinking. That's the kind of thing that I'm thinking. Yes, Jamie, that is the kind of thing I'm thinking. Get a case for that. No, I've never had cases for any of my phones. It's downstairs, but I would show you my HTC U12, which I had for 5 years, and it still looks almost immaculate. No scratches on the glass, rear glass is perfect, the bezel is almost perfect. So yeah, I don't like what's the point of buying this really beautiful tactile device, yeah? This thing that's like beautiful and tactile and just like slim and lovely, if you're gonna go and put some janky like rubbery kind of case on it. That's just me. I look after my phones, and my brain is very connected with like, oh, taking that out of your pocket. Don't wear jogging bottoms and get out the car. Don't put it down on a desk where there's like some gritty sand or dust or something that's going to scratch it. I am super, super careful with where I put my phone down, how I carry it, where I put it. Don't mix it with keys, all that stuff. I'm super, super careful with that. So I'm not going to get myself a phone case, and that's famous last words. I drop mine often. I've only ever dropped a phone once, and it did smash the back glass, and I was so cross with myself because up until that point I had never dropped a phone and smashed the glass, like ever, and that's in like, well, I don't know, what was my first phone when I was like 13 or something, so that's getting on for like 20 years. In 20 years I had never dropped a phone and smashed the glass, but it happened, I think it was like 6 years ago, and I was so angry with myself. I was wearing a pair of shorts and the pockets were much smaller than I was ever used to, so I knelt down to get something out of the fridge and it like spilled out of my pocket onto some hard floor. But usually I'm aware of the type of pockets I've got. Anyway, we're getting off topic. Jogging shorts. Yeah, jogging shorts. See, that's the thing. I'm not the type of guy that wears jogging pants like tracksuits. I wear jeans with like nice deep pockets that stay tight, or I wear cargo pants that have like a zip pocket or something like that. I don't bowl around in freaking tracksuit bottoms. I'm not one of them mans, you know. I'm not roadman like that, so therefore my phones never fall out my pocket, because the pockets are like decent on jeans and stuff. So, but I guarantee that over 80% of mans in the live chat are wearing a pair of shorts in the winter, like kind of that soft cotton shorts, like pajama kind of material, or jogging bottoms all day long. Even with a shirt, I see mans wearing like a Hawaiian shirt and jogging bottoms. Like, bro, that is a look. Sheesh. So we're just going to slide this back into the case so that we can connect up the pin headers here for the MCU and for the 12 volts, although I actually need to go in that way first to just slide under the fans. And then down, and then we can lock into our pins here. Come on, there's just enough space on there. Get that up there. Get that up there. There we go. Lovely stuff. Love to see it. Love to see it. You get in there. There we go. Excellent. Right. So now we're slid back in. This is a beast, isn't it? This is a big boy amp. So now we slid back in there. I'm going to apply some power to the board. And I'm just going to quickly check my soldering job on the MCU. Just make sure I did a good job on that. I'm just going to use some nice fine tweezers just to kind of wiggle away at the legs, make sure there's no loose legs on the MCU. They all look pretty well soldered, to be fair. Yeah, that looks fine, that's fine. So now we're going to remind ourselves what the damage was to the original MCU here. I think that it lost one bank of PWM output to the power supply side. So let's get some power going in. We can just clamp one of these power supply cables onto the positive, which is going to be literally just on this freaking massive rail here, which is pretty convenient. And the negative side, we can go anywhere on the case, to be honest, or because this amplifier uses the whole case as ground. So yeah, we could probably just go on there maybe. Well, yeah, even just on the case. Can I find a nice bit of metal or a nice easy access ground? Maybe I'll just go over here, to be fair. There we go. Yeah, we can just ground onto there because that's literally case ground, so that's fine. I think we've got a ground pin. Does this have a ground pin? I don't want to create a high resistance ground because obviously this isn't screwed down. So I want there to be a decent ground either by a pin or something. Yeah, there is a ground there, that's cool. Actually there's two grounds there on that header, so that's fine. And yeah, we have continuity there, and just want to make sure we have continuity on the source leg. Yeah, we do, yeah, so that's fine. And then also our remote wire as well, we just want to connect up to the remote there. Get the oscilloscope turned on for the first time today. Well, actually no, not for the first time today. I've been working all day. I've been working all day today. Could that band of 15K be much smaller looking at the output side? Potentially, yes. You could squash up the components on here, make it be smaller. However, there is something to be said about having the size, because then that gives you more thermal mass on the heatsink. The case is the heatsink. So by it being this big, it has much higher thermal mass to wick away heat from the IGBTs here on the output side and dissipate it through the heatsink. So I'm not mad about that. A 15K amplifier is going to create a fair bit of heat, you know, when it's doing big power like that. So I don't mind that they went for a big case like that. It's fine. Bit of room to breathe as well. Yeah, no dramas there. For a temporary fix, you could try to add some pull-up, pull-down resistors to the outputs, since usually only the output buffer in the MCU dies. In this case, unfortunately, Seddon, I don't think I get any PWM out of one of the banks at all. So let's have a look and remind ourselves what we have. Let's have a look and remind ourselves what we have. So I'm just going to push that over there and zoom in a bit on the output board, because that's where we're going to be working on pretty much. Now, I've just done a repair to the drive circuit in the power supply here, and I don't know whether there's like any leaking voltage or anything around any of the drive ICs that we did the soldering job on. So I want to turn the power supply on and start nice and low. So we're starting down at just 1 amp here, 1 amp, and I'm going to slowly increase the voltage and just make sure that there's no parasitic draw. Okay, there is. We've got 0.3, 0.4. Okay, so there is a bit of parasitic draw there. Let's take our thermal imaging camera and let's see what that is and what's getting hot there. Right, so I suspect it's going to be a drive IC perhaps, or it might even be the MCU. It might be dead to the point where it just kind of like has a short from the VCC to ground, which would be really annoying, which means we'd have to use one of the reprogrammed ones. But so 0.3 amps there with 3 volts. Let's see what starts sort of getting a bit warm. I don't know if that's going to be enough current to tell us, but okay, got something here. Here we go. There we go. That drive IC there is getting warm. Okay, that's not good. Let's check some of the others over here. That one's okay. And that one there is okay. That one there is okay. Okay, so something here is not right. Okay. So before we can continue, we need to have a look and see what's going on with this drive IC right here. Actually, is that only one of the ones? Actually, you know what? That's the only one. No, it's not. This one also has. I was going to say that's the only one that has a 4R7 VCC to it. So that's interesting. What about this one over here? Is that one getting warm as well? Oops, I disconnected my ground wire, didn't I? Let's reconnect that. Okay, 0.5 amps. .40, 42 degrees Celsius on that one. That one there's fine. So yeah, there's something a little funky going on with that one. Just want to quickly investigate what that is. So here we are. Unfortunately, there's a capacitor in the way, so you can't really see this, which is really annoying. But I don't really know if I can lift the board up in a way that you can see, because it's kind of in the case now. Maybe like that. It's just going to slide. Yeah, thermal imaging is literally a godsend when it comes to repairs. So we've got VCC on the 4R7 here. So I assume we either have a short to ground there, which we don't. We have a pretty high resistance to ground there. What else do we have? So we have VCC going in on pin 2 here. Pin 2 VCC going in. Ground on pin 3 there, okay. Oh no, wait, that's not supposed to be ground on pin. Where's ground supposed to be? Ground's supposed to be over here. Pin 7, right. And we did just temporarily have. Weird. Can you see my multimeter? Is my multimeter camera working? No, of course it's not working. Of course it's not working, it never works. Even though I cut the USB end off and soldered a new one, it still doesn't work, so it must be a problem with the actual camera itself. Very, very frustrating. Can you see it now? Nope, it's still just frozen. Why? Why? New multimeter cam definitely is required. There we go. Right. So I did just have from ground continuity a little bit to pin, what is it? Oh sorry, no, it is pin 6. Pin 6. Pin 6 here. And what's that supposed to be? Pin 6 there is supposed to be... it's supposed to be A. Okay, I bet I've got a solder bridge. Yeah, look, I've probably got a... I think there's something funky going on there. I've got like a low resistance between the gate and the 12 volts there, but then it's kind of charging a capacitor. Really strange. What's that all about? So there's no solder bridge, but something is shorted. Volts there on the drain. It's like charging a cap, so it's not actually shorted or connected anywhere. Very strange. Ah, there we go. There's our short. So we have a short between the drain there of that pad and pin 1, 2, 3, 4, 5, 6, 7. Right. How has that happened? Pin 7 is usually... What's pin 7 usually? VCC, ground. Okay. There we go. Right, so there is a short or solder bridge or something under the board probably. We have a short between gate and drain on this bank here. So yeah, it could just be a little solder bridge under the board that I've missed. So let's go ahead and have a little butchers under the board. See if we can find one. Yeah, thermal imager is literally a game changer, guys. If you're working on electronics, yeah, thermal imager will literally pay for itself in like a small handful of, you know, only a small handful of repairs that you do, and it will have paid for itself in the amount in your time. It's super cool. So that was over that side. So do we have a little solder bridge that I've missed? It's easy to do. I don't see it. I don't see it at all. Very strange. Well, let's just get a sharp thing and scratch between all of the pads here anyway, just in case there's like a hairline one that you can't see but that's there anyway. That might have been it. There was a bit of resistance there, so that might have been it. Okay, that might have been it. No, so it won't be shorted inside the driver because the drivers are brand new ones I've just fitted. So the drivers are brand new, never been powered. The most that they've got is 3 volts just then that I slowly ramped up just to make sure that nothing was going to be drawing any current or shorted, which obviously it was. So it's a good job that we did that. So the drivers are brand new and okay. But I think that was a little solder bridge that I just found there, so it was very tiny, but it did have a little bit of resistance on the sharp pokey boy that I was scratching with. So okay, let's get rid of that. There. Okay, so let's put our power wires back on again and just power that back up again and make sure that the parasitic draw has gone. 12 volts into this side over here, onto the rail, 12 volt rail, and ground literally anywhere on the case. I'm just going to go on here. So let's start off again with the power supply nice and low. and gently increase the voltage. So yeah, there we go, it's gone now. See that? 0.01. That is not actually 0.1, that is just my lab power supply that isn't calibrated. It always displays 0.1 for some reason. So yeah, we're going up to 5 volts, 6 volts, 7, 8, 9, 10. There we go. Yeah, that's all good. And just make sure, just have a little probe of the gates, make sure there's no DC on any of the gates. Well, obviously there wouldn't be, because if there was, then we'd get current draw. So that's good. Okay, fantastic. Now what I'm going to do is I'm going to hit the remote, and the remote is going to get the MCU alive. It's also going to start sending some VCC to some of these drive ICs. These drivers over here, most of them don't have their 4R7 resistor to connect 12 volts to their VCC. So most of them aren't going to come alive, but 2 of them are. This one right here that was getting warm there, and this one over here is going to come alive because that's connected to a 4R7 as well. But the rest of them haven't fitted a 4R7 yet. So I'm just going to briefly, just for a split second, touch the remote, just make sure there's no excessive current draw. We're only letting 1 amp in at the moment, so okay, yeah, excellent stuff. We get 0.5, that's the fans. I'm actually going to unplug the fans over here just to remove any current draw that's unnecessary while we're doing these tests. So 0.3 amps worth of current draw, that's pretty good. What we're going to do is probe this middle header here with PWM1 and PWM0 written, and that's going to show us which one of these banks from the MCU has failed, because this MCU that I fitted is the original one that has 1 oscillator down, and we're going to use the MCU's oscillator hopefully. Okay, there we go. Well, there's a little bit of pulsing there. You can see it's tiny, tiny. So this I think is the failed side of the oscillator. Yeah, tiny, tiny, tiny. Oh, it just came back a little bit there, maybe. Okay, so it's very, very low duty there. And then eventually it goes full duty. There we go. So that's very, very small. Nowhere near big enough, I don't think. So if we probe the other PWM... Huh, no, you know what? I think that's the one that works. Although weirdly, it's so small. That can't be right. Yeah, I think both of these are damaged, in fact. That is so tiny. That is literally just above, is about 3, what's that, about 3 volts peak to peak, which is nowhere near enough. So that one's dead, and the one next to it, the PWM1, so that's PWM0, PWM1 is absolutely nothing. We just get a little bump of DC there. So yeah, but there probably is enough PWM left on PWM0 for us to use this to our advantage and use that to control pin 4 of the TL494 in a way, in a fun way, to vary the duty cycle of the TL494 as the amplifier goes through its health check, which it normally would anyway. So let's turn our attention now to the main event of this stream, which is going to be trying to retrofit a TL494. So we're going to obviously have our attention all the way over here at the MCU side of the amplifier. Let's go in here. So what does a TL494 need? It needs a 12 volts supply. So let's have a little poke around here and see if we can find a 12 volt supply anywhere. I'm pretty sure we have a 12 volt supply coming in. We can make our own 12 volt supply off the remote, obviously. Let's just have a poke around here and see if we get a 12 volt supply coming in anywhere from these headers. Here we go. We've got a 9 volt supply there. If I increase the power supply to 12 volts, hopefully that will give us... We've got 11.7 volts. That's probably the remote wire, and that's a fixed 12 volt. So, do we have a switch 12 volt that's not the remote wire? We've got a 3.3 for the MCU, another 3.3, and ground. Then you have other voltage regs around here, so that's all that uses. Actually, to be fair, hang on a minute, no, if the MCU is only being fed with 3.3 volts VCC, then that tiny amount of PWM that only goes up to about 3.3 volts peak, that is then fine. So we do have working PWM0, but PWM1 is dead on this MCU. But that's fine, that's cool. That means we can use PWM0 to control the TL494 duty cycle. So that's really, really cool. But I don't think that there is a switched 12 volts anywhere around here. But for now, that's fine, because what we'll do is we'll just connect the TL494 to our remote wire temporarily in this instance while we're testing this circuit. Then once we get this retrofit working, we can then disconnect the remote wire from the TL494 that we've got from this bench test setup, and we can then put in our own 12 volts auxiliary supply, some kind of transistor setup like they have in most amplifiers. Oh, Big Man didn't tell me he was live. No, sorry dude, it was a bit of a rushed one to get this live stream going. Apologies for that. But I'm glad you're here now, bro. How's it going? I didn't want to disturb you either. Yeah. So let's grab a TL494 then, and let's just find first of all our remote wire coming in. So our remote comes in, and let's just see if it's on any of these pins over here, any of these kind of jumpers here. It's probably going to be. Let's have a look on any of these transistors over here. There's a diode here. Oh, there we've got 2.8 volts. That's going to probably be our 3.3. That's our 3.3 right there. And is that being fed? There we go. There's our remote. 11.7 pretty much. Actually, you know what? That is... No. That 11.7 is actually a switched supply, because my remote voltage is 12.6 on the remote wire. But there, I forgot on these amplifiers, there's a little switched 12 volt circuit down by the power terminals, and this voltage here, which is the input to this voltage reg that gives out 3.3, is only 11.7. So that is a switched supply, so we can literally just use that. Fantastic. We'll go off this little capacitor here, I think. There we go. We'll go off this capacitor, and that's where we're going to take our supply for our TL494. Excellent. So let's grab a TL494 out of the drawers, and I think I'm going to go with a dip package, just because the pins are going to be easier for us to solder to. Now, this is not going to be a pretty mod. This is just going to be a quick mod to get this amplifier up and running for a competition for this customer. So I think we're literally just going to glue glue the TL494 in place on the board like this. And then run some jumper wires to it just to get this amplifier up and running. Okay, so don't judge, but it's going to look a bit funky. Now we obviously need to denote which of these pins is 1 and which is, which is pin 1. So pin 1 is over here on this side. So maybe I'll just make a little scratch with something sharp, maybe like a little knife blade or something, so we can remember from the underside which one is pin 1. Find a knife blade somewhere. So pin 1 is that one right there. Top. There we go. So I've made a little scratch, just literally to tell me which one's pin 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so let's get some glue and glue our 494. Uh, 13BTR says, in the Smart 5 bass, or is the Smart 5 bass as good as the Smart 3 bass in your opinion? The first batch of amplifiers that they released, they were not really built very well. There was a huge risk of vibration damage to the output inductors shorting to the main board, but I believe they've corrected that in more recent times with newer ones. I don't know how you tell other than by taking the back off and having a look, but provided you're buying one brand new, yes, they're very, very good amplifiers. I do think that they should be using different FETs than I think initially they were using 4127s in the output side. No, they should be using 4227s. 4127s not really anywhere near as good. So I don't know if they changed to 4227s at any time, but yeah, they're still fantastic amplifiers. They're still fantastic amplifiers. Yeah, the Smart 5 bass is pretty good to go if you get one of the newer ones. hot melt glue. No, not hot melt glue. That's jokes. Oh, I think that's a reference from another live stream I did a while ago. Some guy was like asking about, he was like asking questions, and he was like saying about using hot glue in the amplifier, and like as if he'd been doing that for a long time. And I was like, no, dude, what are you doing? You can't use hot glue. Is the frequency clock inside the chip? So basically, yeah, the frequency clock is generated internally in the MCU. It has an oscillator built in, so there's no crystal or anything on the main board that we need to worry about. Everything's done in there. And in order to set the frequency for the TL494, the TL494 has its own oscillator as well, but we do need to run some external components to set up the oscillator for a specific frequency there. So the first thing we're going to do is literally just connect a 12 volts supply to our TL494 and a ground. So our 12 volt supply is pin 12, which is 9, 10, 11, 12 over this side. You know what, I probably should have actually flipped this around and glued it the other way around. Yeah, you know what, let's glue it the other way around. That's definitely going to be better for us, because 12 volt and ground is over that side. So that's how we should be doing it, and all the pins on the other side are generally sort of like calibration pins that you set externally, so it's better to glue it that way around for sure. There we go. So 9, 10, 11, 12 is right there, so let's turn our soldering iron on and get that connected to our 12 volt supply. So, bit of fresh solder on to C26. This is where our switch 12 volts is going to come from. Muy bien. The TL494 is 30 years old chip design. Yeah, it's a super ancient chip, but we're using it here because it is tried and tested to not glitch or have any issues where it's going to cause the power supply FETs to explode. We could use an SG3525, but that just overcomplicates things a bit. We don't need all the functionality of the 3525. The TL494 is just a chip that I know very well, and it's literally all we need here to create some pulses to drive these MOSFETs. No need to overcomplicate something unnecessarily, so it's a nice tried and tested way of creating pulses for driving a SMP in a car amplifier, so no need to, there's no benefit really to going with anything more complicated than that in this case, because all the protection circuit is still going to be controlled by the original MCU anyway, which is the modern way to do it. 9, 10, 11, 12. Right, so there's our pin 12. So we just need to go ahead and connect that to pin 12. And we also want to connect it not only to pin 12 but also to some other pins. I'm going to bring up a data sheet of the TL494 here, and we'll see what we want to connect it to. So if I just go to the screen here, TL494 data sheet, again super old chip. We also want to connect 12 volts probably to pin 13, because I think that sets the chip into push-pull mode. Here we go. So 12 VCC, 13 is output control. So we also want 12 volts connected to pin 12, and I think we also want, no actually that's fine, C2, yeah, that's going to be ground, I'm pretty sure. Or is it going to be 12 volts? C collector, the collector might have to be emitter. Yeah, no, we're going to want 12 volts, I think, on pin 11 and 8 as well, if I remember rightly. Although actually, we don't need 12 volts on. We don't need 12 volts on there. We want whatever voltage we want to. Yeah, whatever voltage we want to drive into our drive ICs is what we want on C1 and C2. So we could either give C1 and C2 3.3 volts from the MCU supply, which will result in some very, very small little 3.3 volt peak to peak pulses, or we can connect C1 and C2 to the 5 volt ref generated internally on pin 14, and that will give us 5 volts peak to peak pulses, or we can connect it to 12 volts and give ourselves 12 volts peak to peak pulses. So what do these drive ICs that I fitted, what do they want? Let's just take a 4427 as a reference. IR 4427. Now, what are you okay having into your inputs? V in, the maximum is VS, so VS fixed supply voltage. So yes, whatever you've got on VS, you can go into V in. But just to keep things safe, just to make sure that it's, you know, not above VS at all, because we do have a different supply for the actual supply for the drive ICs is going to be a different supply chain, a slightly different supply area to the 12 volts that we're going to be giving, or the 11.7 volts that we're going to be giving to our TL494. So I think what I want to do actually is connect C1 and C2 to the 5 volt ref. Robert, here's my comment. Thank you very much for your comment, Robert Davidson. Appreciate you, buddy. So yeah, so we want to connect up pin 14 to 11 and 8 to give us the voltage that the pulses are going to swing up and down to. Cool. So we just want to connect 12 volts to pin 12 and pin 13. And we also want we want to tie pin 15 and 2, we also want them connected to 5 volts, 5 volt ref, and we want pin 16 and 1 connected to ground, because we're not going to be using the built-in comparator or amplifier. I don't think we're going to be using that at all. We're just going to be using pin 4 for dead time control to shut down the power supply when a fault occurs. Because this TL494 is not, we're not controlling the entire protection and everything with the 494, we're just using it for its oscillator. So with that in mind, 9, 10, 11, 12, 13. So yeah, we want 12 and 13 together. So let's chop that off a bit because it's a bit too long at the moment. There we go. Get that bent down around 12 and also around 13. Okay, let's get that soldered in. Okay, so we have our 12 volts and we have our control pin calibrated for push-pull operation. Now we need ground. So like I said, there's a few pins that we need to connect to ground. We want to connect pin number 7 to ground. That is the ground pin. So let's just find a point of ground on the board. It's probably going to be the other side of that capacitor. Yep, it is. Is there another one that's nearby? There we go, there's another one that's more nearby. So we're going to go ground there, pin 7, 1, 2, 3, 4, 5, 6, 7. There's also ground here by the looks of it. So yeah, we'll just go in there, why not? Screw it. There's literally a very convenient hole there for ground. So let's go in there. I'm actually going to use a longer wire here for this, because I'm going to just extend, I'm going to use this long wire because we're going to extend this all the way around to all of the pins it needs to go to. So if I just strip this with, here we go. Token Tombstone. Wow, I think Token Tombstone is a little bit behind in the stream, but for when you get here, Token Tombstone, how's it going, buddy? Good to see you. He probably is not going to see that for another half hour or so. He or she or they. But yeah, how was everyone's weekend? What did you guys get up to, huh? Anything audio related? If anyone did anything audio related at the weekend, let me know. Do you have a prototype kit? I don't think I do. Oh, I'm here now. Thanks for doing the stream. Oh, okay, jokes. I assumed maybe you were a little bit far behind in the stream because that donation was a little while ago. But no, cool. Good job. Thanks for joining. Right, let's put the put this long wire into our little ground hole here and get that soldered in place. Then we can start wrapping it round everywhere that it needs to go. It might not actually even be long enough to go everywhere that it needs to go. We might have to extend it a little bit, but that's fine. Like I say, this modification here is not designed to be pretty or like, you know, factory or anything like that. This is to get the amplifier back up and running as quickly as possible for a competition, so no judge. So we want ground on pin 7. We also want ground on ground on pin 1, 16, 7. I think that's it. Yep. 1, 7 and 16. Don't think we want it anywhere else. Is there an example circuit just on here? So sometimes you get an example circuit. There we go, there's an example circuit. So we do want ground as well on the RT and CT pins, but after the resistor and capacitor, that's fine. Error amplifiers, yeah, we know we want ground pin 16, pin 1 we also want. This is the just test circuit to get up and running. This test circuit operates the outputs in a slightly different way. It has the outputs oscillating on pins 11 and 8, whereas usually it's set up to have the outputs oscillating on 9 and 10. Either way is fine, but I think we're going to have it. Yeah, we're going to have it set up to do. Yeah, we're going to have it set up to do outputs on. I think we're going to have it set up to do outputs on 9 and 10. We might need some pull down resistors to do that though. Over the weekend I messed around with new mic and car's EQ. Nice! EQing your car and setting up DSP and stuff, you can spend weeks like getting it dialed in, so didn't do much the weekend. The closest to audio related was listening to my speakers. Although that's cool though, because like sometimes you have these really nice speakers and you just don't get a chance to actually just sit down and listen, so that's really, really cool. I finally decided and ordered my sub. What sub did you go for, 13BTR? I built some big tube amps. Those have pretty scary voltage in them, don't they? I'm pretty sure tube amps are like in excess of 400-500 volts, maybe even more. Audio related, I tried building a bipolar PSU using a TL494 and the negative rail keeps dropping and causing a sawtooth. The PSU has a coupled inductor to avoid the issue. Interesting. I hope you get that sorted, buddy. It's always fun prototyping stuff. Saturday I happened to be nearby car audio security event. Oh nice, pop down there and not going there ever again. Seemed a bit of a time waste. Sunday glued second DD9921 new largest round. Excellent stuff. What are you doing with the 9921s, by the way? Wow, 1050 volts. Yeah, fuck that. No, I'm good, thanks. Went with the HS24. Nice. Decided against the infinite baffle. Against the infinite baffle. Okay, so you're going with what, a large sealed or large ported? What made you decide against infinite baffle? Maybe the high frequency response? Because yeah, the high frequency response does take a bit of a hit in IB. What are we saying? 1, 2, 3, 4, 5, 6, 7. So let's spin 7 over here. Let's make a little fork there. bring that there. And then we want pin 1 and 16. Okay, there we go. That'll do us. That'll do us for now. Let's get those soldered on. Chris from, I'm scared of 90 volts. Yeah, I'm scared of, as soon as it hits 100, I'm like, a little bit careful. And then as soon as it hits like 150, I'm like, and then as soon as it hits 200, I'm like, and then when it hits 400, I'm like, wait, where's my, oh, I think they're downstairs. As soon as it hits 400, I'm like, safety glasses, fucking. Sealed, yeah, 30 to 80 hertz is more important to me than 18. Yeah, that's fair enough. If that's the case, and sealed was the right choice for you, my man. That is a fair enough. Okay, there's our grounds. A lot of people do a front sub to deal with the lack of bass above 45. That's basically what my T-line door cards do in the Proton. They're nuts. They're freaking crazy from like 53 hertz up to, well, 200 and above if you wanted to go that high, but they start locating a little bit. They are freaking potent. Yeah, it sounds incredible. I wanted to keep it somewhat simple. The HS24 actually modelled almost identically to the IB24. Really? Other than the HS having more mid-bass. The low end was identical, aside from it taking twice the power. Weird. You should have, like, sometimes modelling things doesn't always work out to be how it's going to perform in real life. I'll take that with a pinch of salt, but that's cool though that you're still going to get some decent low frequency response with the HS, so that's cool. Nice. Hello Sergio, how's it going, buddy? Okay, so we've got ground and we've got 12 volts. Fantastic. Now what we want to do is connect the 5 volts ref to the collectors. So we want pin 14 connected to 8 and 11. 14 to 8 and 11. So pin 14 is 10, what is it, pin 14? 9, 10, 11, 12, 13, 14. So this pin right here, we want that connected to 8, which is annoyingly all the way over here, and 12. 9, 10, no, sorry, not 12. What is it? 8 and 11. 9, 10, 11. So here and here. So this pin right here, and this pin right here, need to connect to this pin right here. Okie dokie. That should do it. Me and my brothers used to get electrocuted with 220 volts all the time when I was installing crappy Christmas lights in the 80s and 90s. Damn. Tickles a bit. With AC though, you are definitely safer because you can let go with AC. If it's DC, you can't let go if it bites you hard. So it's definitely not what you want. I used to work on radar displays, 2800 volts. When the hair on the back of your hand stood up, it was time to rethink your movement back out slowly. Yeah, fuck. I'm so glad that I don't have to deal with any of that crazy nonsense. Pin 14, there we go. Okay, let's get that soldered in. Cool, cool, cool. Right, now we need... Oh, I also forgot. Damn it! I should have just run a little bridge over that. We also want these two pins, pins 2 and 15. We also want those connected to the 5-volt ref as well. I completely forgot about that, so I'm just going to bend over that one that I forgot about, and then this one over here. Just going to bend that over this way. Make a new little jumper, because that's going to prevent the error amplifier from shutting down the oscillator. There we go. Excellent stuff. So So that's now 5 volts connected through to everywhere that needs to go. Right, now what do we have left? We have pins 9 and 10 that obviously need to go to our drive ICs. But we're going to do that once we've set the frequency, etc. We have a few more things to do. We need to set the frequency. So I'm wondering, does the datasheet have? I can't remember actually. Here we go. I'm going to power the. I'm going to power this up, and I'm going to see what frequency the original MCU was sending to the drivers. So if we go PWM0 here. That is, oh, that's pretty low frequency, hey? That was about 19 kilohertz, I think. It can't find it. Oh, there we go. 20. There's a lot of noise on here, so it's kind of struggling to find it. Maybe I should attach a ground probe. I get so many questions. There's so many questions that are like, oh dude, how are you doing this without a ground probe? Well, I'm doing it just because the power supply is common to my oscilloscope ground, but because obviously the ground path is long, it does induce a lot of noise when you're measuring small waveforms like this. So when you're measuring small waveforms like this, it definitely does help to have connected a ground clip to your oscilloscope probe, like we're about to do now. Just click that onto there. That should help us to read the waveforms a bit cleaner. Oh, that's so much bloody different. Look how much better that is. Yeah, there we go. Right, so that is, yes, 19.8 kilohertz. It's pretty slow. Why did they choose such a slow frequency for the power supply? You can see there, that's the dead oscillator trying its best in the MCU. Godfrey says, these circuits you should make beforehand and just connect your wires. Absolutely, but we don't have time for that. This amp was literally delivered to me a couple of days ago, and I had to order all of the drive ICs and all that stuff, and yeah, literally don't have time for that, unfortunately. And I thought I wanted to do it on stream for you guys as well, so you can see the process. But this is fun. I want to experiment with T-lines, but I don't have any wood to build a box. Maybe long PVC pipes could. Well, yes, long PVC pipes is a T-line. No driver offset or tapers. Yes, you're right in that sense. I tried sealed ported enclosures in the door, and I was never happy with them. Oh, really? Yeah, the T-line door cards are insane. So 19 kilohertz we need to calibrate on the 494. Now we calibrate that with a resistor and capacitor combo. So I wonder whether the datasheet gives us any indication for what values should be used there. We could obviously just use a random capacitor that's kind of the right value, and then a potentiometer to calibrate the frequency before fitting a fixed resistor. Here we go, timing resistance. This graph right here, let's see what we got there. Amplifier voltage application versus frequency. Timing resistance. So if we want, what was it, 20 kilohertz, about here. So with a 1 microfarad capacitor, we want a, what's that, resistor that is, no, wait, oh yeah, sorry, no, sorry, frequency's up this side. Okay, sorry, for 20 kilohertz, which is there, for 20 kilohertz we need a 0.01 microfarad capacitor with a what kind of resistor is that? Like 4K, 5, 6, around about a 6K resistor. Or we can go for a 0.001 microfarad with a much higher value resistor. Looks about the same number actually, just with another zero added. Okay, well let's see what capacitors we've got laying around. What's a 0.01 microfarad? Is that 10 nanofarads? I really suck with the microfarad and nanofarad. I can never remember how many zeros it is. So, so 0.01 microfarads is 10 nanofarads. Okay, so we need a 10 nanofarad capacitor. Let's see what we've got cooking in the capacitor drawer. It's probably going to be a surface mount cap. At that size, it's probably going to be a surface mount, like a little ceramic maybe. Or one of those like little disc looking capacitors. Let's see what we've got in here. Film caps. I do have some brand new film caps that are pretty small that might work. Might be the right, so here we go, the right sort of value. So let's see what capacitance is this bad boy. That is 1,000 picofarads, which is oh, okay, that's not big enough. That is 1,000 picofarads is 0.001. Okay, so we can use this capacitor, but it would be. So we can use this capacitor I've just found, but it would be on this curve right here. So we would want then a sort of 56K or something like that, maybe 60K, something like that, which might be harder to find. So I'd like to try and find a 10 nanofarad if I can. Let's see what else we've got in here. A little box of goodies. Ah, here we go. What are you? What are you? Okay, that's 6,700 picofarads. So, with that one, that is 0.006. Now it's not big enough still. What are you? 470N. So I think you're what are you, 470? Oh, you don't, Tesla doesn't even know. There we go, so 470 nanofarads, that one, which is way too big. So we've gone too small and now we've gone too big. So something in between that and that. What's this one? 104. 100 nanofarads, too big. So we want a 103, like a capacitor that says 103 on it. I don't think I'm going to have one of those. Maybe a really small little ceramic or something. Ah, 56.3. That might be, that is 50 nanofarads. Now we might be able to calibrate one with that. 55 nanofarads, so that is along this line here. So we're going to be somewhere in between here and here. So that means we're going to want quite a low resistance value here, I think. Maybe like around 2K. But ideally we want something that's not going to change with the temperature. So this is quite important. This graph is telling you how much the frequency is going to change with temperature. So frequency variation is the change in oscillator frequency that occurs over the full temperature range. Oscillator frequency variation. So with the percentage here, is that the percentage of change? Minus 2%, 0%. So I think ideally we want to be on this kind of curve around here somewhere, rather than right over here. But a 2% change shouldn't be the worst thing, so. You could use the 1 nanofarad with a 27k resistor. Could I? That could be cool, that could work. 1 nanofarad with a 27k. Okay, well let's try it. Let's try it. Let's go with where was the 1 nanofarad that I found? What was it? Where's the 1 nanofarad that I found? 104, here we go. Wait, did I have a 1 nanofarad? Did I have a 1 nanofarad? Oh, I did, didn't I? I have 1,000 picofarads is 1 nanofarad. Right, let's try it. Let's try it. Let's give this capacitor a go to ground. So we're going to have one of these legs connected to ground and the other leg is going to be connected to the resistor. So let's cut the leg there for that. So ground. We're going to go to ground there, and then we actually go to ground here. So capacitor to ground. So pin 5 is the capacitor. Pin 5 is the timing capacitor. So pin 5 is 1, 2, 3, 4, 5. So that's the timing capacitor to ground. So that's just literally going to hang across there. Excellent stuff. Let's get that turned on. Bit of flux. Okay, so there's our timing capacitor. So now we also need a timing resistor, which is from pin 6 to ground as well. I was just talking to Josh Lind about trying this not too long ago for Bandit amps. Well, let's see whether this is going to work. What's up, Timbo? Dusty Myers, we're repairing a Bandit Viking 15K with a dead MCU by retrofitting a TL494 oscillator. So, in order to calibrate the frequency, I'm going to start off by using a potentiometer. And this potentiometer here in question goes up to 100K, so that's going to give us plenty of range to go by. And once we've got the resistance dialed in, we can then obviously fit a fixed value resistor. That's not a very good connection. Needs a bit more flux. I'm pretty sure I did put some flux on that. Flux. Okay, and then also ground. Alright, cool. That's going to allow us to calibrate the frequency. Excellent. The last thing that we need is probably to pull pin 4 down. So 3, 4, pin 4. I can't remember if pin 4 gets pulled down internally or not in these, but we're going to start off with, let's turn this up, get the frequency somewhere around about there. So let's turn this on and let's see what kind of frequency we get out of pin 9 and 10. And see if we get anything yet, because we might need to pull pin 4 down. I can't remember if it gets internally pulled up or not. Okay, we've got nothing on pins 9 and 10. So pin 3 is low, pin 4 is high, up at 3 volts. So I'm just going to pull pin 4 down temporarily. We're going to want to do something with pin 4, something clever with the original PWM coming from the MCU. But just for now, we're going to ground it so that we get output from the chip. So let's just temporarily latch that onto our ground over here as well. But this isn't permanent because we want to connect pin 4 to something else later on. Okay, so we should now get output from the 494. Yeah, pin 4 was currently at 3.5 volts, that's why it wasn't outputting anything. So it gets pulled high internally, that's fine. So now we should have something coming out of 494. No, okay, we still don't. Why do we still not have anything coming out of 494? It's interesting. Pin 4 is low, pin 3 is low. Pin 5. We've got sawtooth on pin 5, right? So that means we should have output on pins 9 and 10, right? What have I missed? What have I done wrong? We have something. It's try. Oh no. Ugh. Pins 9 and 10 are doing something weird. Have I done something wrong with the collector maybe? So I've connected. This is the test circuit that we're not looking at right now. I've connected 5 volts to 11 and 8. Perhaps that's wrong. Perhaps that should be connected to ground instead. I can't remember. Let's just grab one of these. I think I've got an example in here. There we go. Here's an example TL494 oscillator. So pin, what was it? Pin 11 and 8. Oh no, they should be connected to ground, I think. No, what are they connected to? Not connected to anything. I bet you I've chosen an example circuit here that uses pins 8 and 10 as the outputs. Yeah, I think I have. That's not what we want to do. I think we want to use pins 9 and 10, not pins 8 and 11 as the outputs. That's how like 99% of car amps I've seen work, so let's find one that does that. I suppose we could use 8 and 11, but I'm used to seeing 9 and 10, so that's what I want to do. Just want any random ass circuit that uses a 494. It's accessible. Here we go. Here we go. Donnell to the rescue. Here is an in-phase IPA something. So let's have a look at this one for a sec. For a minute. I can't get this at the right bloody height to have a look at. we go. So pin 8 connects to not ground, but yeah, pin 8 connects to 12 volts. On this example circuit here. So that's basically what I've done. I've done the same thing. So why doesn't mine work? Pin 8 and 11 connect to 12 volts. I've done pin 8 and 11 connects to 5 volts, which should be the same kind of thing, right? So why doesn't mine work? Sam says, I think it's to do with the resistor in your collector to emitter line. You've got nothing to drop the potential across. You'll be pulled up to your 5 volt ref with the transistor open or closed. Well, I'm not. I've got 0 volt. I've got 0. So if I go pin 9 and 10 here, pin 3 is floating. Pin 9, 10, 11 is 5 volts. What have I done wrong? Now see, the potentiometer is okay because I've got the sawtooth wave on pin 5. So if we check pin 5, I've got a very nice sawtooth wave, which is very, very fast here. Let's just change the frequency of the sawtooth. .35 kilohertz. We want 19. So there we go. That's the frequency that this circuit oscillates at from factory. So I've got that. So why don't I have anything on 9 and 10? I don't understand. What am I doing wrong? It's got to be something to do with pins 8 and 11. And on any generic car amplifier, they're connected to 12 volts. I've got them connected to 5 volts just because I didn't quite want a 12 volt peak to peak wave being sent to actually no, hang on a minute. The frequency on the 9 and 10 is half that of the it's half that of the sawtooth. So if I want 20 on the outputs, then I need 40 on the sawtooth. So that's going to be up here. There we go. That's what I want. But yeah. Oh, not resistor, transistor. A transistor in your collector to emitter line. You've got nothing to drop the potential across. Oh, I see what you mean. You'll be pulled up to 5 volt ref with the transistor open or closed. What's the value of the potentiometer right now? You won't be turning the transistor on because you need 0.6 volts from base to emitter, and your emitters are floating at the moment, aren't they? Yes, the emitters are floating at the moment. So do I need the emitters with like a pull down or something on them, like actually connected to something? So shall I put something on the emitters, like a high resistance to ground perhaps? Maybe I should just connect them to the circuit. Yeah, let's connect them to the circuit where they need to go and see what we get. So the emitters need to be connected to PWM 0 and PWM 1 of the circuit. Maybe because they're floating in the air, they're not doing anything. So let's but I've never actually floated pins 9 and 10 from a 494, so I've no idea really whether, you know, whether they should work or not like that. So oops, if I just turn the power supply off for a sec. Let's probe PWM 0. That needs to go to that was originally going to the MCU via this pin right here. There we go. That's PWM 0. I don't think that goes through a resistor at all. I think it's just literally straight traced. Yeah, it's straight traced over there. So can I find the trace on the board? Here it is. Right, there's the trace. So I need to run a jumper wire from there to pin 9, and where's the next one? Here we go, these two. So these two on the board here, these are our PWM 0 and 1. So we need to run little cables from here to pins 9 and 10 on the 494. And then it might start working, might start oscillating, who knows, but yeah, let's see. We still might need some extra circuitry to get that working, but this is the bit that I've never done before, so we're just kind of learning as we go. I hope this is educational and entertaining at the same time, because I do not design circuits, so I don't know what the bloody hell I'm doing, to be honest. I'm just good at fault finding, you know. I'm not good at design a circuit. Never before in my life design a circuit, you know. Yeah, there is a resistor in line with the PWM out of the 494 and the drive IC, because they have high value resistors in line before it gets to the PWM input, so that's fine. So we don't need to add our own resistor at the moment, because it already has one on the board for that purpose, which is pretty cool. Some random guy from the street said, just tried the chip with my lab bench. The emitters switch without being connected. Connect 8 and 11 to the VCC pin. I've got 8 and 11 connected to the 5V ref. Can you just check whether they still switch with connected to the 5V ref? Because I thought that would work. I thought that would just mean that then I had 5V peak to peak PWM rather than full 12V peak to peak. You know what, I'm going to avoid going right next to the output inductor because that might be kind of noisy. Might induce some noise there, which isn't ideal, so yeah, let's go to there, like that. Okay, that's pin 10 connected. You can use a Zener to cap the output. Oh, Alexander, that's a great idea. Straight up kick you. How's it going, man? Just tuning in. Good to see you, buddy. Yes, I could use a Zener. That's a really, really good point. Could use a 5.6 Zener, for example, to cap the output if it's a bit too high. Good point. I might do that anyway, actually, just to make sure that the voltage never swings above VCC plus 0.3 of the drive ICs, because they don't want anything more than that. Okay, so that's now connected, but yeah, I don't have a very strong feeling that that's going to work, because I feel like I need to connect pins 8 and 11 to 12 volts for some reason, which is kind of annoying, but because I've already done all that work and connected all that stuff up. But let's just see what it does anyway. No, get absolutely nothing. We get an attempt. You can see that. Oh, hang on a minute. Oh, hang on a minute. One's working. Ah, no, hang on. Oh, obviously, it's still connected to the bloody MCU. I need to cut the trace to the MCU, obviously. Right, let's cut the trace to the MCU, because otherwise it's going to be fighting itself, isn't it? So. Right, that trace there, and right, these two traces right here. So let's cut those to disconnect them from the MCU. This board is much stronger than others that I've done trace cuts on. I could do with a sharper knife, to be honest, but it's whatever. Right, there we are. Trace do be cut. No more connection to the MCU. Okay, cool, cool, cool. Right, yeah, so like I say, I don't think, yeah, we don't have anything on any of these from pin 9, I'm afraid. Pin 9 and 10. So does pins 8 and 11 have to be connected to 12 volts, not to 5 volts? I don't know, let's try it. Let's cut our wire here from, you know, let's not cut it, let's maybe let's just desolder the wire here from pins 8 and 11 that leads to the 5 volt ref, and let's connect it to the 12 volts supply. Did I do too good of a job of getting this locked in? I think I probably did. Yeah, let's just cut it because I've done too good of a job of getting it locked in. So let's cut it, and then we can always, like you said, we can always use a Zener to clamp the voltage, which probably would be worth doing anyway, over just having the chip decide. So let's just solder that onto the 12 volts coming in there as well. Okay, so let's see if that makes any difference then. Nah, still nothing. What am I doing wrong? What am I doing wrong? We just have 200 millivolts on 9 and 10. Why? I don't get it. Zero volts on pin 3 feedback. 0 volts on pin 4 dead time. So we should have output, but we don't. I don't get it, man. What am I doing wrong? Pin 3 must be greater than 4 volts or you won't get output. No, it's the other way around, Michael. Pin 3 must be 0 volts. If it's above 4 volts, then you won't get output. If pin 3 is high, then that means that the air amplifier is shutting down the oscillator. Pin 3 needs to be low to operate. Is it that pin 9 and 10 need a pull up? Is it that pins 9 and 10 pull down to ground? No, they can't, because the collector's got 12 volts on it. It doesn't make any sense. I'm just seeing whether pins 9 and 10 on this one have any resistors that connect to 12 volts in, like any pull-up resistors. No, that's ground. Yep, so that's a resistor to ground on pin 9. Pin 10. That's another resistor to ground. What is the resistance to 12 volts? 150k. So on this example circuit here, I've got 150 kilo ohms between 12 volts and pins 9 and 10. Check page 9. Let's have a look at page 9. Page 10. Okay. Oh yeah, 9. Maybe I should just do it how they have it set up here. Pins 9 and 10 to ground, and pins 11 and 8 connected to the PWM lines. This is figure 8.4. Wait a minute. Figure 8.1, figure 8.2, figure 8.3, figure 8.4. Where's figure 8.4? Is that this one here? Emitter follower configuration. Is it supposed to be here? Or is it above? No, figure 8.4 is this. So each output circuit, 15 volts, which is what we've got going into the collector, and then on the output we have a little capacitor to ground and a resistance to ground. Pins 9 and 10 should have two 470 ohms against ground for the driver inside the chip. This should be so bloody simple. Why is it not? I've got 1.6k on pin 9 and 1.64k on pin 10. My camera's not working, but yeah. The emitter being at ground and the collectors used as output. with the emitter being at ground and the collectors used as output, you'll get high output during dead times. That's not what I want. So I need this configuration here to work, yes. But my man here on the live chat said that with 9 and 10 floating, he got output. So I shouldn't have to have anything connected to 9 and 10. I am so confused. What is wrong with this? I don't get it. What have I done wrong? I might have to leave it here for tonight, guys, and just experiment with a car with a car amplifier power supply drive card that's, like, you know, already assembled, and see what I'm doing wrong, what I'm connecting wrong here. Some random guy says, for me, 8 and 11 get 12 volts from the main supply pin and the emitters float and there is an output. Yes. Feedback pin is 0, and when I lie to the error amplifier that there's a voltage, the feedback floats up to 4.6. Yeah. Your emitters have no reference to the circuit unless it's through the driver input. Yeah, they do have a reference to the circuit because they're connected to the main board that has a reference to ground. They have the emitters here on my circuit board have a 1.6 kilo ohm to ground, so they have a ground reference. The resistance that they have to 12 volts supply looks like, I don't know, 33 kilo ohms. Let me give you my multimeter camera. Hopefully it's going to connect and stay active for a bit. So yeah, on the multimeter we have from emitter to ground we have 1.6 kilo ohms, and from emitter to the 12 volt input we have 30 something kilo ohms. Why is it not switching? I don't understand, bruh. I don't even get like a little waveform. I don't even get like a little one. It's just nothing. Did I just pick a bad chip? Is this chip just fucked? It's brand new though, so I don't understand why. I might have to come back to this tomorrow, guys, with a fresh head. It's absolutely baffling me, not gonna lie. The internal 5 volt ref, yeah, that is at the proper voltage. The internal 5 volt is currently sitting at 5.0. Yeah, it's dead on. Well, I guess the only thing we can do is remove the 494 and just whack another one, just in case this one's like not any good. I don't get it. At least we have all of our jumpers and stuff ready to go, so we can just very, very quickly probably just swap it out. So frustrating. Right. Should I try a surface mount one instead? Maybe this whole batch of 494s I've got is no good. I don't know. I've used these in amps though and it's been fine. We know that I had the orientation correct because we had a sawtooth wave on the pin, whatever it was, 6, which we wouldn't have had. 1, 2, 3, 4, 6, 7, 8, 9, 10. There we go. Someone said it looks like you have your output control pin connected to VCC instead of VREF. Oh, you know what? That might have been it. Fuck. That might have been it. You know what? That was probably it. That was probably it. Yeah, I think I had in my head that VREF either needed to be high or low, so I had it connected to VCC, whereas, yeah, I think you're right. Usually it's connected to VREF 5 volts, so getting 12 volts into the output control might have been screwing up the mode of operation a little bit, so that's probably what our problem was, but unfortunately I didn't see that in time before changing the 494. VCC pin 12. So I'm only going to have VCC connected to pin 12. I'm going to use 5 volt ref for everything else, the collector and also the yeah, obviously the mode of the operational mode of this. So 9, 10, 11 and 8, like we said, are connecting to 5 volts ref, which we want to do with one of these. That there, and pin 9, 10, 11, 12, 13, 14 is ref. So we want 13 and 14, 9, 10, 11, 12, 13 and 14 connected together. There we go. And also 15, we also want 15 connected as well, because that will make sure that the error amplifier stays not killing the output. I'm sorry about this, guys. This is just like a bit of a hassle, really, isn't it? Okay, so that's all connected to 5-volt ref now. So yeah, we've got ref, 5-volt ref on that, and then one more just bridging over from there to there. Excellent stuff. So now we just want our timing capacitor and resistor connected. Maybe we'll do our resistor first this time. So ground and resistor there, and capacitor there. Alright, we're almost there. We're almost back ready for a test, I think. Okay, and last but not least, we need the jumper to pull pin 4 to ground. God, my iron's literally just not quite long enough. Come on. Come on, bend round there, you bastard. There we go. Fucking hell. Right. Ground. Timing. Resistor. Pin 4 ground. 9 and 10. Right. I think we're finally ready for a quick test then. I've not been looking at the live chat. I just want to try and get this done as soon as possible because it is super late here in the UK now. So let's see whether that now works. Okay, thank the bloody God for that. Who was it that said that the mode was wrong? Good job. Right. I needed to have the control connected to 5-volt ref, not 12 volts. That was my fault for thinking that it was just a high or low signal and that I could connect it to 12 volts ref rather than to 5 volts ref. Right, anyway, so we have our output on pins 9 and 10. Woo! Freaking let's go. So that should now be making its way down to the drivers down here. One of these has 12 volts on it. So if I now oh yes, look at that. We have PWM on the MOSFET gates over here and over here. Excellent. So yes, this is now working correctly. However, we're finished for tonight, but we're not quite finished for this mod, because what we need to do is we need to have the MCU here still control the dead time of the PWM coming out of this 494. Okay, that still needs to happen. So, in order for that to happen, what we're going to do is somehow connect up the original PWM 0 line that still works from the MCU, which is on the oscilloscope. We turn that up a bit and connects my ground probe so you can see what that's supposed to look like without all of the ground noise. Is it this trace here? Here we go. So this is what the MCU usually sends to the drivers. It sends out little pulses like this, and then it goes full duty. So what we need to do is somehow get this to control the dead time of the TL494. The problem is that the dead time pin on the TL494 is maximum dead time, aka off, when no, sorry, not dead time. Sorry, not dead time. Duty cycle. It's late. It's like 11:30 in the evening. Right. We need this waveform to control the duty cycle of the TL494. Okay? And the problem is that we could just rectify this. So if we rectify this PWM coming from the MCU, then we'll end up with a low voltage to start with, and then ending up with a high voltage when it goes full duty. like that, up to about 48% duty cycle. The problem is that the TL494 pin 4 works the other way around. Pin 4 wants a low voltage for operation and a high voltage for basically off, or 0% duty. So we need to invert, we need to rectify this waveform from the MCU, then we need to invert it. So I'm thinking just run it into an op-amp, run this, the rectified DC from the original pulses from the MCU, run the rectified version of that into the inverting input of an op-amp, and then run the output of the op-amp into pin 4 of the TL494 with some kind of pull down or some kind of voltage divider to calibrate the exact voltages that we need to give us the dead time curve that we need, so the duty cycle curve that we need. So yes, please invest in a small pack of IC test leads. I will do so, technical specialist. Thank you very much. So this is I don't really do circuit board prototyping or anything like that. I'm a repairman, so I rarely need to do this sort of prototyping jazz. So I don't have lots of stuff that would be best for that. But yeah, maybe I need to invest in some. Could you just feed PWM0 through a resistor into the base of an NPN, which then pulls the TL494 pin low through an RC low pass? Isn't an yes. Oh, yes, maybe. Could you just feed? I will experiment with that. That's a good idea, Michael. So I will change, yeah, I'll have a little play tomorrow. So basically this is tonight's stream done. Tomorrow's live stream will be experimenting with exactly this. Getting the original MCU's PWM0 to control pin 4 of the TL494. Op-amp seems overkill. Yup, the NPN should invert it. Okay, maybe we'll do that then. Yeah, little NPN, little surface mount NPN or something on the board. Feed PWM through a resistor into the base of an NPN, which then pulls the TL494 pin low through an RC resistor, RC low pass. Yes, I'd need PWM0 on the base, and then the emitter to pin 4, and then the collector would be to ground, wouldn't it? Because it would be, yeah. Collector to ground, emitter to, I hope I got that the right way around. I'm honestly so bad when it comes to transistors and polarity and stuff. I think it would be collector to ground, emitter to pin 4, and then base to the PWM. I shall try that tomorrow, gents, but thank you so much for sticking with me through this one, guys. This looks like an absolute mess, of course, but we're just trying to get this up and running as quickly as possible for my guy. So tomorrow's live stream will be continuing with this, where we try and get that control working with the original PWM, and hopefully it'll be nice and simple as suggested in the live chat. Oh, emitter to ground, collector through resistor to TL494, and a cap to ground plus pull-up resistor, plus a pull-up resistor. Yeah, oh yeah, I think the TL494 does pull it up internally anyway, but it wouldn't be a bad idea to have a pull-up resistor anyway. Thank you very much, Michael. Honestly, can't thank you enough. That's a really, really great suggestion. I wouldn't have thought of that myself. So yeah, we'll do that tomorrow. But thanks so much, guys, for sticking with me this evening, and I hope you have a great day tomorrow. And it'll either be tomorrow or the day after that we continue with this, but hopefully it'll be tomorrow because I need to get this one done. So yeah, cheers for sticking with me, guys, and I hope you have a great evening. Hope you enjoyed this stream and maybe learned something, and I'll see you tomorrow. Bye.